morning, students. We'll just wait for another 1 minute because I can see only four of them have joined. Just in 1 minute, we will get started. Okay, then we'll begin. Let others join, and later, if they have any doubts, let them ask me. I know that you all have my mobile number. So, if anybody having any doubts during my explanation or during our discussion, you can just personally post me so that I'll just read out that particular query and then I'll give the answer for that. Let me first tell you. So you are already aware that your exams are commencing from 10th December, 10th November onwards, and your exam pattern is also clear to you that you will be having only part B, that is 8 questions will be given to you, out of which you need to answer any 5. That means each question carries 14 marks, and each question may also have A and B questions also. That point also you need to understand. It's not guaranteed that each question means there will be only one single question. So one question may carry again two sub questions, where again each sub question may carry 7 marks. So this is what the weightage. And coming to the unit wise classification, so the first 6 questions will be from the first 3 units. That means the first 2 questions will be from unit 1, the next 2 questions will be from unit 2, the next 2 questions will be from unit 3, and from unit 4 only one single question. Likewise, from unit 5 also one single question. That means if you can be thorough with the first 3 units, you can definitely attempt 5 questions. And coming to the internal examination, so your mid examination officially will release a circular when it is going to be, and many of them were asking me personally, so what is the pattern and how it is going to be, all that. So don't worry right now. So your mid exam is going to be online only, not that you are going to write it in the college. So in the college, whatever you are going to do is you will be writing your theory exam. Immediately after you complete your theory exam for 2 hour duration, you are going to be writing your lab external. So mid exam you are going to write it from your home only, that is online only. We will let you know when and how. Mostly we will be using quizzes platform, which you are already familiar with, because during the month of April, at that time when I have taken the revision classes, I have already used that quizzes platform, so you are used to that. So using that quizzes platform, we are going to give 25 MCQ based test, and then important bits also will be given to you in advance. From that, you are going to get the exam, which will be scheduling, and we will release the date and time when you are going to appear for that particular MCQ based test. So this is what I wanted to convey with regard to your OS exam. So theory 8 questions, out of which you are supposed to answer 5, and 6 from first 3 units, 2 from each unit, and 2 from last 2 units, 1 from each unit. And mid exam is going to be online based test. That too will be MCQ based only. So all the important MCQ bits with answers will be given to you. Don't worry about that. So if you are able to prepare well in advance, you will be able to secure good marks in the quiz exam also. So this is with regard to your mid as well as the theory exam. And coming to the lab external also, we are going to uh, give you the schedule. So which roll number, which experiment, like that kind of thing we are going to give you well in advance. Accordingly, you can just be prepared with that particular experiment, and then you can appear for that write up also. That practical exam, you are going to have it immediately after you completing the theory write up. So first you are going to write your theory write up in 2 hours. There and then itself you are going to write the practical paper also. So we are not going to ask you once again to come to college and then appear for a practical separately. So altogether you have 5 theory papers. So you are going to visit the college only for those 5 days. I hope this is clear now. Now coming to these revision classes, what I am going to do is I am going to cover each day one particular unit. I'll tell what are the possible long answer questions that might be coming from that particular unit and what you need to write for that particular question. So this is what my agenda is. So altogether we have 6 classes starting from today, and each day I'm going to dedicate it for one particular unit. And today our discussion is going to be on Unit 1 revision. So in Unit 1 altogether we have only 6 long answer questions. We have only 6 long answer questions. So the first and foremost will be the operating system functions. What are the objectives and functions of operating system? This is the first question. And then the evolution of operating systems, the second question. And operating system services, the most expected question, that is the third question. And then the fourth question is what is system call and what are the different types of system calls. This is the fourth question. And the fifth question is what is the use of a system program, and then what are the different system programs. This is the fifth question. And lastly, the design and implementation of the operating system, which is nothing but the operating system structures. So these are the only 6 possible questions from Unit 1 that you can expect from the long answers. So objectives and functions, services will be somewhat similar only. Whatever the operating system functions and the operating system services, you will be having mostly similar things only. And coming to the evolution of operating systems, so it's not mandatory to explain each and every evolution very detailedly. You can just give the type of evolution and then you can just explain in brief, and then you can just mention the example operating systems that fall under that particular category. So this example systems is not required anyway. And coming to the system calls, again you need to mention the all 6 types of system calls. Likewise, system programs also, we have seen 7 types of system programs. You need to explain all those 7 types of system programs. And coming to the OS design and implementation or operating system structures, you need to explain all 4 structures that we have covered during our class. So you need to explain all the simple structure, layered structure, microkernel structure, and the modular approach. All these 4 structures you need to explain. We will see one by one in detail now, but I'm just telling you these are the 6 possible long answer questions that you may get from Unit 1. The functions, evolutions, services, system call types, system program types, and then the structures, all the 4 structures. So these are the 6 possible questions. And whatever the notes I am having, I am going to share it with you, this particular notes I'm going to share it with you. To your group I'm going to post it. But moreover, this particular notes is taken from the Galvin textbook itself. And in the month of April itself, I have already shared you the PPTs. So even now, if you type in the Google like this, OS PPT Galvin 10th edition, the very first reference, if you click on it, you will be able to see this page where you can download the PPTs. And from this, chapter 1 to chapter 17 PPTs you need to download. Chapter 1 to chapter 17 PPTs you need to download. Among all these 17 PPTs, only the 12th PPT you don't require. Rest of all 16 PPTs you require. All the major points that you need to address with regard to any question, you can just find that particular point here, and the elaboration you can just do it. But all the crucial bullet points you can find it from these PPTs, and these are the official Galvin book PPTs only. So leaving the 12th PPT, from 1 to 17 PPT, you can just download the 16 PPTs. And all these 16 PPTs also, not complete slides are required for your syllabus, because your syllabus is bounded to few topics only. So you can just go through that syllabus copy from our college website. Also you can download this syllabus copy, and based on the topic you have it for your syllabus, only that particular thing you can just go through in the PPT. So coming to the first, I would like to start my discussion on this objectives and functions. So here is the lecture notes which I am going to share it after our class. So we have already discussed that these are the three objectives of any operating system. Except for the example systems, generally this entire subject we are going to cover on general operating systems and not to specific Windows or Linux operating system. So on a general note, what are the objectives of operating system? So these are the three key objectives of any operating system. That is, execute the user programs and make user to solve his problems easier. This is what the primary objective of any operating system. And the second key objective is make the computer system convenient to use. So user should be convenient to use the computer for his problem solving. This is what the second key objective. So after writing this particular objective statement, you can just give your own explanation in terms of some real-time scenarios, and then you can just elaborate it. But these are the three key objectives you need to address, and the explanation is left it to you. So you can just pick up any real-time scenario and then you can explain how that particular objective fits to that particular real-time scenario that you have chosen. And the third objective is use the computer hardware in an efficient manner. So these are the three key objectives. The first primary objective is, so execute the user programs in order to solve the user problems easier. The second objective is make the system convenient to use, and the third objective is effective utilization of the hardware. So these are the three objectives you just need to address with regard to the objectives of operating system. And next, this user view and system view, this is not required right now for your exam purpose. And coming to the functions, so these are the functions. Mention all these points. If you forget 2 or 3 points, doesn't matter, but these are the functions you need to write down and explain in just 2 to 3 sentences. I recommend don't exceed 20 minutes for answering any question. I strongly recommend you to restrict yourself not to exceed 20 minutes for answering any question, because you have only 2 hour duration now with this pandemic. So you just need to answer at least 6 questions. I recommend you to answer at least 6 questions within the 2-hour duration. That's why I'm saying restrict yourself to 20 minutes for answering any question. So as I'm saying, these are all the functions you need to write down. But even if you forget 2 or 3 functions, doesn't matter. But make sure that you will be able to address at least 2 to 3 sentences with regard to each and every function. So memory management, it is strictly with regard to the main memory management, because as we have the main memory limited, we need to manage the main memory among several competing processes that are set for execution. So that's what you can just address with regard to memory management. Likewise, processor management. So we have single CPU. I mean, most of the general purpose systems will be having only single CPU, but more than one process will be there that will be there for execution in the main memory. So how this one single available CPU will be able to execute all these multiple CPUs will be performed by this processor management. So whatever I'm saying, you can just write the same thing in your own sentences. Not more than that is required. Likewise, device management. Device management means IO management. Device management is nothing but IO management, because every process during its course of execution will be requiring some IO operations definitely. Either reading input from the user or writing some output, whether it is to the output devices or whether it is to some external devices, whatever it might be. So that device management is strictly with regard to the IO management, how the IO devices are being managed among several processors that are already there in the main memory. So that's what the device management speaks about. Likewise, file management. So when there are several processes competing for execution and they might be requiring some file management, that is, they might be creating new files or modifying some existing files or doing some deletion of existing files, some or the other things. So the file system management should also be taken care by the operating system itself. And security strictly speaks with regard to the defensive against the internal and external attacks. So how operating system is going to make sure that it is going to uh, defense defend the any attacks that happens to the resources of the system. That attack can be internal or external. All the internal and external attacks should be defended by the operating system. That is what the security speaks. On the other hand, protection also you can just address here. Protection and security you can write actually. Rather than just writing security, you can also write protection and security. So security is defending the attacks internally and externally, whereas protection is safeguarding the resources, safeguarding the system resources. That means against any misuse, safeguarding the system resources against any misuse. That misuse can be either by the legitimate users of the system or non-legitimate users of the system, whoever it might be. Safeguarding the system resources against misuse by the users or the current ongoing processes, whether it can be current ongoing processor or it can be some legitimate user of the system. So safeguarding the system resources against any misuse by the ongoing process or the current user. That's what protection. On the other hand, security means defending against internal and external attacks. Likewise, control over system performance. So you need to take the control over in order to make sure that the system performance will be always optimal. System performance should be always optimal. Accordingly, operating system will take the control over. And job accounting. So this is required because operating system will make sure that which users are being in are using or executing their processes and how long they are accessing the resources, and which resources are in demand. So knowing all these things, operating system will have an easy understanding about the maximum resources that are in demand. By knowing that, operating system can make sure that that particular resources that are in demand can be increased in instances. If the resource in demand are increased, automatically the performance will be good. Otherwise, if your operating system maintains all equal amounts of resource instances, then the performance will go down, because same resources may not be in more demand all the time. For that reason, this accounting information will also be maintained by the operating system. Operating system also maintains the accounting information in terms of user time, in terms of process time, in terms of resource time. So which resource, how much time being in demand, which process, how many resources being used, which user, how much time spending is execution. So likewise, all that accounting information should also be maintained by operating system in order to understand the demand of the resources that are more in demand. Likewise, error detecting and prevention. So this is also a crucial functionality of any operating system. It need to keep monitoring the things, and then it need to identify if any errors are being detected, then it need to ensure they are being recovered, and then the execution goes on smoothly. And likewise, coordination between other software and users. So this is established through the communication mechanism. The communication mechanism will also be the responsibility of operating system, which ensures that the software and the users will be communicating when using some resources. So the communication is also one of the important services of any operating system. And we have the shared memory technique or the message passing technique. These are the two techniques that will be used by any operating system in order to ensure the communication smoothly. So these are the functions you need to write down with regard to the operating system functions. So this is the very first question I have said to you. Objectives, these three key objectives you just need to write, and just one or two points you just write down, and just make sure that you don't exceed 20 minutes for answering any question. Accordingly you write down. Don't write too lengthy explanations for any function. So since you already have 9 functions here, so just make sure that you don't exceed 2 to 3 sentences with regard to every function. And this is the first question what I have said you. And next, coming to the second question, that is the evolution of operating systems. With regard to the evolution of operating systems, I hope you do remember what are the various evolutions that we have covered. So we have discussed about the first evolution, that is the batch operating systems. So starting with batch operating systems, we have discussed other operating systems, that is multi-programming, time sharing systems. Like that we have discussed. Let me just go to there. Yeah, here you can see whether the question given to you is computing environment or the evolutions. You need to answer this, whether it is computing environments or whether it is evolution of operating systems. You need to address this. So starting with the batch operating system. So batch operating system means we are going to form a particular batch of jobs, and then we are going to set the entire batch for execution rather than executing one job after other job. So we use batch operating system, in which we are going to process batch by batch. We are going to process batch by batch, and each batch can be containing n number of jobs. Each batch can contain n number of jobs. So that means, because if I just turn on my system for executing one job at a time, then it's not guaranteed that I'm going to get all jobs at once. Then you are going to waste your computing power, you are going to waste electricity, and many other things you are going to waste. And in earlier days, when we used to have this punch cards mechanism, we used to go for this batch operating system because they are expensive at that time. For that reason, rather than processing it for one after the other, we used to go for a batch of jobs, and then we used to process all at a time. And the batch size may vary. It's not mandatory that always the batch size should be same. The batch size may vary. And here, these are the problems that you need to write down with regard to batch operating systems. So once the batch is set for execution, then no interaction is possible from the user. Once the batch is set for execution, no interaction is possible from the user. And then CPU is often idle because the speed of IO devices are slower than CPU. And only one job will be processed at a time. Even though you are setting entire batch for execution, but from the batch, only one job will be chosen for execution. So only one job will be residing inside the monitor, I mean the batch monitor, and then until it finishes and it leaves out, the second job from the batch will not be loaded into the batch monitor. So only one job will be residing inside the batch monitor at any point of time, and until it finishes, the second job from the batch cannot be loaded into the batch monitor. So with this, what happens? We are already aware that CPU is the fastest component in the computer and IO are the slowest components in the computer. So every job will be definitely requiring the CPU for executing the instructions and IO for processing the read-write operations. So whenever there is some read or write operation, it is the job of IO devices which are the slowest components. And whenever there is an instruction execution, it is the job of CPU and it is going to be done faster. So due to these differences of the speed that a CPU executes and IO devices operates, then CPU will be sitting idle for most of the time. And you can't even assign CPU for the second job or the next job in the same batch also, because unless a job of that particular batch will complete and leaves, you can't load the second or the next job into the batch monitor. So with this limitation, CPU will be most of the time idle, and then difficult to provide the desired priority. Definitely there won't be any priorities. Whatever the order of the jobs that are there in the batch, one after the other they will be processed, so no priority comes into picture. So these are the basic limitations with regard to the batch operating systems. And next we have discussed about the multi-programming systems. In multi-programming systems, we'll be having more than one job residing in the main memory. And when we have more than one job residing in the main memory, then whenever CPU is being idle, it can be switched to next job. Whenever CPU is being idle, it can just switch to next job. That is what the advantage of multi-programming. So like this is what the example you can see in this multitasking or multi-programming. So there will be more than one job residing at a time in the main memory, and by default, as per the scheduling policy that operating system is having, that one job will be set for execution, and whenever that particular job that is currently going for execution, if it will be going for some IO operation, meanwhile CPU can switch to other job, and then it can switch like that. Likewise, you need not keep the CPU idle. That's what the multi-programming or multitasking. This is the second evolution that we have discussed. And then we have discussed about the time sharing systems. So in time sharing systems, it is also quite similar to the multi-programming only, with the only difference that in multi-programming, user interaction will not be there, whereas in time sharing systems, user interaction can be there. This is the key difference you just need to address when you are saying with regard to multi-programming or the time sharing systems. So in multi-programming, user interaction is not going to be there, whereas in time sharing systems, user interaction is going to be there. And even with regard to time sharing systems, you need to explain about the round robin scheduling, because there we are going to have this particular round robin or time slicing technique, where we are going to assign some particular time quantum for each and every job, so that all of them are going to get equal chance for getting executed by the CPU. So these are the points you just need to address with regard to the time sharing systems and multi-programmed systems. So multi-programmed, no interaction; time sharing with interaction, and a time bound will be set for giving equal chance for all the jobs that are there in the main memory. And after the time sharing systems, we have discussed about the real time systems. We have discussed about the real time operating systems. So under real time operating systems, the results are to be immediate. The results are to be immediate. And one more thing I forgot to mention about the example operating systems or example jobs, which you can write with regard to that particular kind of thing. So with regard to batch, you can just write down the example like credit card billing or the postpaid telephone billing. All these things you can just mention with regard to the batch operating system, because each and every transaction that you are going to make, whether it is with the card or whether it is with the postpaid, for each and every transaction you are going to make, you are not going to be billed. So a batch will be formed from a certain date to a certain date, and all the transactions that are being made will be just recorded, and then the will be made on a particular date at a particular time only. So this you can just explain in your own understandable way with regard to the batch operating system. And coming to the multi-programmed system, you can just explain the best way, example is all the modern operating systems are multi-programmed and time shared systems only. All the modern systems are the multi-programmed and the time shared systems only, where we are able to interact during the execution also. And yeah, next coming to the real time systems, as mentioned, real time systems are the one which should produce results immediately, which should produce results immediately. So whatever the home appliances you take, those things also you can just take some of them as example for the real time systems. And we also have discussed the classification of the real time systems, hard and soft real time systems. So in hard real time systems, so all the things must and should complete on time without any delay. That we consider them as hard real time systems. Whereas soft real time systems, you can just consider where the results should complete, but if they are not as expected on time, if there is some delay, that can be tolerable. That can be tolerable. Such systems we call as soft real time systems. So this is the basic classification with regard to the hard real time systems and soft real time systems. So in hard real time systems, results should be on time without any delay. A small delays are also not tolerable. Whereas soft real time systems, there can be slight delays. Slight delays are tolerable. And we have also discussed during our theoretical discussions that under hard real time systems, you can just pick up the example like stock exchange systems and the nuclear power control systems. So where you can't have any kind of delays tolerated. Under soft real time systems, you can just take the example of multimedia systems or some movie ticket reservation system, something. These examples you can consider, because there, if there is some delay, like when you are trying to download a movie, if there is some delay, or when you are watching some video, if there is some buffering, we can tolerate such delays. So that doesn't affect much in terms of economy or in terms of some lives also. So for that reason, we consider them as soft real time systems. So this is the third evolution And then we have discussed about the, after this real-time systems, we have discussed about the distributed operating systems. So distributed operating systems also you need to explain. So I have given you an equation that distributed operating system is equal to network operating system plus transparency. So you can just write down that equation, and you can just put it in a box, and then you can just explain how distributed operating systems plays major role in real-time application development. So you'll be having systems scattered across the globe, connected over a network, and each and every system that is scattered across a globe in a different locations can be having its own nature, like all these systems that are connected across the globe may be of heterogeneous nature. That means each and every system might be having its own underlying platform differently, and its own different operating system, whatever it might be. But all these systems will be working for some single cause, will be working for some single cause, and they all look like something like they create an illusion that they are not different systems at different locations across the globe. They are all one single system. That's what the image they create. So all these systems across the globe, they create an illusion that they are not different systems, they are all together a one single system. This is what the ultimate goal of any distributed operating system. So any distributed system's ultimate goal is to create a single system image. This is what the point you just need to address when you are writing about the fourth evolution, distributed systems. So as mentioned, you can just write down distributed operating system is equal to network operating system plus transparency as a one single equation. You can just put it in a box, and then you can just write ultimate goal of any distributed system is to create a one single system image despite of being at different locations across the globe. So they are situated in different locations across the globe, connected over some network, and the network operating system is responsible for having the communication established despite of the heterogeneous nature of these systems across the globe. But yet they create an illusion of being one. Despite of being many, they create an image of being one single system. So this is what the ultimate goal of any distributed system. And next you can also explain the multimedia systems. Next you can explain the fifth evolution as multimedia systems. So where you can write down the multimedia systems like the speed variations, you can just write down. If you can just explain the speed variations with regard to the multimedia systems. And you can explain when we say multimedia systems, it refers to both audio as well as the video, and the downloading rate, how it have changed. All these things you can just explain. And then after the fifth evolution multimedia systems, lastly you can explain about the handheld systems. Handheld systems. So this is the sixth evolution I have explained you. So these are the six evolutions you can just explain. Handheld systems are those systems that you can hold it in your hand, which are nothing but our smartphones and the tabs, all these things, where you have many challenges, because operating system has many challenges, because when we have these handheld systems, the power that the battery produces is also very less, and then yet it need to perform all the applications executions with the limited power. All these things you need to address with regard to the challenges faced by operating systems with respect to these handheld systems. So these are the six evolutions you just need to write down with regard to the evolution of operating systems or the computing environments. Whether the question is asked as computing environments or evolutions of operating systems, you need to write down these six. Batch operating systems the first, and then the multi-programmed operating systems, and then the time sharing operating systems, and then the distributed systems, and then the multimedia systems, and lastly you need to address the handheld systems, where you can have the devices held in your hand. They can be the smartphones to the tabs, whatever it is, palm tabs, or anything. But more challenges are there with respect to the handheld systems because of limited screen space and limited device size. All these things, challenges are more with respect to the handheld systems. So you can just put it in your own statements. So That's the second question that I have said you. And coming to operating system services, so this is the second PPT that you can just find it, and you need to explain this simple diagram. Yeah, you can just put out this diagram there. If you can draw this diagram, if it is difficult for you to remember this diagram, I recommend you to just mention these 8 points. If you are capable of remembering, because this is one of the most important and expected question. Operating system services is one of the most important and expected question. I repeat, so this services is very important question from the unit 1. So as mentioned, if you are capable of remembering, you can just draw this particular diagram, because this speaks the entire computer system. This particular diagram speaks with regard to the entire system, where you can see user and other application programs, and then the user interaction which can be possible with these four ways. So user interaction is possible with the GUI or touch screen or command line interface, or the yeah, these are the typical user interaction. Actually batch also can be included here. Under the user interface you have four types: GUI interaction, command line interaction, touch screen interaction, and batch interaction is also there. But yet batch is not supported by all operating systems, no problem. And then system calls, and then the services. These 8 services you need to explain, guys. So program execution, the support in terms of editors, loaders, linkers, all these things will also be supported by operating system for making sure that a program can be executed. So the all the editors, loaders, linkers will be supported and will be coming under as part of this program execution. And coming to IO operations, all this device management, uh, read write operations with regard to various IO will be coming under this IO operations. And file systems, which I have already discussed with regard to the OS functions. Communication, this also I mentioned. So the message passing and shared memory techniques you can just write down under this communication. So the processes will be communicating with regard to the message passing mechanism or the shared memory mechanism. These are the two ways how processes will be communicating to one another. And then the resource allocation. So resource allocation is one of the major service of any operating system, because we will be having limited resources, and a resource can be a file, a resource can be a device, a resource can be a CPU cycle, a resource can be a memory block. Anything can be a resource. A resource is nothing like compulsory it should be a physical component only. A resource can be a memory block in the main memory. A resource can be a file which is physical. A resource can be some IO device which is physical. A resource can be CPU clock cycle, which is again not physical. So something like this, anything can be considered to be a resource. So all this resource allocation will also be one of the crucial service of any operating system. And accounting, I have already said you with regard to the OS functions. Error detection also I have already said you. Yeah, there I have again said this protection and security, again the same. So protection means safeguarding the resources against any misuse by the legitimate users or the ongoing processes, while security is defending the system against any internal and external attacks. So these 8 services you just need to address. So this is why I said OS functions and services will be coming hand in hand. Services and functions will be coming hand in hand. So they will be more or over same only. So this is what the 8 services you need to address with regard to the operating system services. Loaders, linkers, editors come under program execution. IO devices, read write functional operations come under operations. File systems, creating of files, manipulating of files, deleting of files, opening of files, reading of files, closing of files, all these things come under file systems. Message passing and shared memory techniques are the two means of communications. And resource allocation, as said, a resource can be a CPU clock cycle, a file, a device, a memory block within the main memory, something like that. Accounting information for having the knowledge of which resources are in demand. Accordingly, those resources can be improved or increased for making the performance smoother and much better. Error detection always required to keep the system always ready for processes. Protection and security the same. So these are the services you just need to address, guys. And next, coming to the system calls. So system call is a service or an interface, you can tell. System call is an interface which is used to uh, get a service executed, get a OS service executed. So that's what the typical system call is all about. System call is nothing but a function kind of thing which is used to call a particular service. Whichever service that the user application requires, that particular service cannot be directly executed by the user application. In turn, that particular service can be requested by making appropriate system call. So each and every system call will be having a unique number associated to it. Whenever an ongoing user application will be requiring certain OS service, will be making a system call, and then that particular will be transformed to the corresponding number, and that particular number service will be invoked by the operating system after doing some verifications whether this service request is a valid one or not. If it's a valid one, then who is requesting it, and then it will be executed. So these 6 type of system calls you need to address, and there will be a diagram actually. Yeah, this diagram. So this diagram is very important. So if you are able to draw this particular diagram for system calls question, you will be able to get full marks. Definitely you will be getting full marks if you are able to draw this particular diagram for system calls. This box, I mean, because all 6 type of system calls are addressed here, and in Windows and Unix, how they are being called, I mean how they are invoked. So that's why for system calls program, it would be great if you will be able to draw this particular box. So this is the 4th question I mentioned. This is the 4th question I said you. And coming to the 5th question, system programs. So again the classifications are going to be the same. So these are the 7 category of system programs you need to answer. So all these 7 categories of system programs you need to address with regard to system programs. So if you carefully observe, whatever the system calls we have seen, almost the same things you are going to find again in the system programs. The only difference you just need to understand is, so system call is making a call to a particular service, whereas system program is the actual implementation of that particular service. It's something like that. So system call is something like you are making a function call to a certain operating system service, whereas system program is the actual implementation. It's the code that contains for performing that particular functionality. Whatever the functionality you are mentioning now, so for that particular functionality, it's the actual implementation. That's the basic difference you need to understand. So system call acts as an interface between the user application and the OS service. System call acts as an interface between the user application and the OS service. So it's just a call. It's just a function call. And whereas system program is the actual code. It's the implementation which contains the implementation. So this is what the system program is all about. And lastly, the 6th question that I have said you, that is important from Unit 1 is operating system structures or the design and implementation. You need to explain the 4 structures, that is the simple structure, layered structure, microkernel approach, and modular approach. So these are the 4 structures you need to explain with regard to the operating system structure or the design and implementation. So these are the 6 important questions that are expected from Unit 1. So under operating system structure, you can just explain this simple structure, and then diagrams are not important, guys. Diagrams are not important for this exam. So you can just mention the simple structure and examples, MS-DOS and earlier versions of Unix, which functionalities are not segregated. So you don't have the separation among the functionalities. All are put under one single level only or layer. You can just say All functionalities are put under one single level or one single layer, where no separation of the functionalities are there. So that's what the simple structure. And then the layered approach, where you will be having uh, services split into several layers. Layer 0 will be containing the hardware, and layer n will be the user. So the system, how this layered or architecture will be laid is something like each and every layer can only get the services from the lower layers, and no layer can get any services from the above layer. No layer can get any service from the above layer. So every layer can get services only from the below layers, and no layer can get any services from the above layers. So such a way only the layered architecture is laid, and typically there will be 5 to 7 layers used by any real-time operating systems. So this is what the typical layered architecture. So for this diagram is must. And then the microkernel approach. So in the microkernel approach, the ultimate goal is to reduce the load on the kernel. So the kernel code will be reduced. How the kernel code is reduced is some of the services that the operating system will be providing in the kernel area will be produced as term of system programs. In terms of system programs, they are produced. So when and where the user requires, those services can be executed in the user area itself, so that the burden in the kernel will be reduced. So by this, the kernel size will be reduced, thereby performance will be improved. So, but user area will be overburdened. Because some of the services are removed from the kernel area, and they are being installed in terms of user area itself. So that's what the demerit. And coming to the modular approach, which uses the object oriented approach. Modular approach is which makes use of the object oriented approach. And Solaris example, you can just draw it in the exam. So easy installation and deinstallation is possible with the modular approach. Any service that is required can be easily installed, and whichever service is not required can be uninstalled. So that's what the modular approach is all about, which makes use of the object oriented approach. So these are the 4 structures you need to explain as part of the operating system structures, that is simple, layered, microkernel and modular approach. So these are the 6 important questions with regard to Unit 1. Operating system functions, evolution of operating systems or the computing environments, operating system services, system calls and types of system calls, system programs and types of system programs, OS implementation structures or the operating system structures. So these are the 6 important questions from Unit 1. And as mentioned, you can just type in the Google OS PPT Galvin 10th edition, and then the very first link itself, if you click, you will be able to see this particular page. And here, as mentioned, leaving 12th PPT from 1 to 17, the 16 PPTs are sufficient for you. So in tomorrow's session, we are going to discuss the important questions of Unit 2, and then we will discuss the answers for the Unit 2. Thanks for attending the session and have a good day.